For problem number 1, we're going to start by writing out our reaction, and then we're going to find the moles of the gases produced. So we'll start with CO2, beginning with the grams of our reactant, and then we will use that reactant's molar mass to find the moles of reactant, and then we will use the molar ratio of CO2 to C6H8O12 and 4 in this reaction to find the moles of CO2. And then we will repeat the process with N2, the other gas produced, starting with the grams, and then using the molar mass, and then using the molar ratio to find our moles of N2. And then, because we're just going to find the final molar mass of all of the final pressure, we can just add the moles of these two together for the final problem. So we'll add the moles of CO2 to the moles of N2, and we'll get our 0.028065 moles of gas. Then I'm going to change make our 4.274 cubic centimeters. We're going to change that to liters because that's what we need our volume to be because of R. So we will multiply that by, it's 1 cubic centimeter is 1 milliliter, and 1 milliliter is 10 to the negative third liters, and that will give us 0.004274 liters. And to find our temperature in Kelvin, we'll start with our 337 degrees Celsius that we were given, and add 273.15 and get 610.15 K. Then all we have to do is P equals nRT, PV equals nRT, and we will do P equals nRT over V, which means that if we input all of the numbers that we found in the first three steps, we will find that the total pressure is 328.9 atm. For question 2, we are asked to find the molar mass of gas D. So to begin, I will find the molar volume of gas C so that we can eventually find the molar mass of gas C. So it's basically PV equals nRT, and then we move it around to get V over N equals RT over P. The pressure we're given in torr, so we divide 460 by 760 to get 0.605 atm. And the temperature we're given in Celsius, so we add 273.15 to get 320.15 K. And then if we input that all into our RT over P, we find that the molar volume is 43.45 liters per mole. And then we use the density we're given, which is 4.21 grams per liter, and we multiply that by our 43.45 liters per mole, and that will cancel out the liters and give us 182.9 grams per mole as the molar mass of gas C. Then we're going to find the rate for gas C, which we're given 21.3 milliliters and 3.86 seconds, and because the other one is in milliliters per second, we don't have to change it to liters, so it's 5.52 milliliters per second for gas C. Then we're going to find the molar mass of gas D now that we have all the information we need. So we know it's rate A over rate B equals the square root of molar mass B over molar mass A, and I'm just going to replace the A with C and the B with D to make it easier. Now it says gas D is under the same conditions, so we can assume volume C equals volume D, so we can cancel those out, and that leaves us with, for algebra, we do time D over time C squared times molar mass C equals molar mass D, and that means 17.9 over 5.52, all that squared, times 182.9 grams per mole equals the molar mass of D, which is 1,920 grams per mole.